Hello everybody and welcome to our today's heat event, Quality of the Ground Coffee. First I want to say that we are all vaccinated and tested, so we are very safe during this session, and I'm very happy that you joined our live stream. My name is Carsten Ehling, I want to add, sorry.
Hello everybody, my name is Thomas Elsoff. I am an R&D engineer here at PROBAT. I'm responsible for the R&D plant technology and also involved in the new development of the sensor technologies.
Yes, what is also important during this session, if you have any questions, just feel free to ask. You can use our chat function, or you can contact us afterwards via email, as you like. Yeah, so what we are doing today is we are looking into the process after roasting. So what happens after roasting with the roasted bean, what happens during the grinding process, and at least what happens in the ground coffee silo. Therefore, we made a video clip a few days ago in our R&D center, and we use a lot of our equipment to look in this process step by step. We can't produce this in our live session because there is still work going on right now. When I look sometimes into my notebook, this is just to keep an eye on the chat function, as I said before. Now it's time for our video, so grab your cup of coffee, relax and enjoy our video. Have fun while watching. Hello everybody and welcome to our today's topic, Quality in a Capsule. My name is Carsten Ehling. I am an area sales manager responsible for the Scandinavian market, and today we are talking about the process after roasting. So what happens to the roasted beans over the grinding process and what ends in a capsule at the end. So you will see all this will have an impact on this quality. Here with me there is Thomas Elsoff from the R&D department, and he will tell you now something about our R&D center.
Yes, thanks Carsten for the introduction. So here in our R&D center in Emmerich, we have the possibility to show our customer and everyone who is interested in coffee roasting our roasting technologies. So from the lab roaster to the shop roaster and all the industrial size roaster we can show you. So also the technologies that is new on the market that we are tested here in field before we go to the customers. So when you're interested in roasting, come to Emmerich, bring your coffee with you, and we roast it together, and we show you the performance and how is it taste from your coffee on our roasters. So Carsten, I think we start now with the coffee process or the grinding process, and we start with the filling in process.
Yes.
And we start with the big bag.
Oh look, the big bag just arrived at our filling station. Of course, you have some more opportunities to bring in the coffee. Maybe with smaller bags you can bring it in here, or you can use mobile stations, or if you have a roast coffee silo. Inside the roast coffee silo there are special spiral chutes to protect the roasted coffee beans because they are very sensitive after the roast coffee process. After that you have the opportunity to bring the coffee, in our case with a vacuum system. The vacuum system is for very long distances like 80 or 100 meter. The coffee is transported very fast, and if you use this solution, then you have to pay attention that you don't have so much bends inside the system, because every bend is a potential danger for the roasted coffee bean. Then you have the opportunity to use mechanical equipment. The mechanical equipment is for shorter distances and for slower but more gentle transportation. At the end, all the equipment is a little bit cheaper. And now the coffee is transported via our vacuum system to the grinder. Yes, now we are at the grinder. The roasted beans are in the hopper, and between the hopper and the grinder there is a slider which let all the beans inside the grinder. So if he opens, all the beans fall into the grinder. Inside the grinder, we can take a look here inside. There are two different stages. The first stage is for pre-crushing the beans, and the second stage is for fine coffee. So after that you have a quality of filter coffee or coffee for a capsule. If you want to take control more over the fine particles, we have also a solution with 3 stages. This is our best solution when it comes to grinding. There are a lot of more advantages, like we have separately driven rollers, we have an automatic gap adjustment, and so on. You can also have these grinders gas tight, because within the grinding process the degassing starts. And yes, now we move on to the densifier. This is our densifier. The densifier is to crush or destroy the skins out of the roasted coffee beans that can't be ground or are in the ground coffee. Since this is our latest development of densifier, it has the best efficiency when it comes to densifying the coffee. And you can reach about 30% of densifying with this solution. What is also very important to say is that you can install the densifier afterwards. So if you have an old densifier or an old mill, you can integrate this system very easily. At least all the ground and densified coffee falls into this hopper. From there it goes into the piping system. This is a pneumatic piping system, and when the coffee falls into the pipe, every time it falls into the pipe there is air settled between the coffee portions, so that you have in the piping system coffee, air, and then it flows through the pipes and ends up there at the separator. At the separator the coffee is separated from the air, so that you have only ground coffee on top of the ground coffee silo. Maybe you are wondering why we have so long distances. This is why we want to show you that we can reach so long distances. And now, when the coffee is on top of the ground coffee silo, it falls into the coffee silo, and there a kind of degassing process is starting. And Thomas will explain to you how we can control this process and make it a little bit more stable.
Yes, like Carsten said, now the process is coffee falls into the silo. Here in our R&D center we have 2 silos, one gas-tight silo and one normal silo. In field, so the customer have different possibility. Now we have a round design, and also we have a container, or we have edge silos, so different types are possible. Here we have 500 kilogram silos, and in field we have possibly up to 4,000 kilogram. So what's now important for the gas-tight silo? To save the aroma of your ground coffee, we flush the silo with nitrogen to keep the aroma and the coffee fresh, to have no oxidation there for the coffee. And we make it with different levels of nitrogen flushing, and we make it over lances around the silo. We flush this with nitrogen. We have 2 possibilities, one before filling in and one during the storaging time. So what happened during the storaging time? is that the degassing process that starts, like Carsten said, during the grinding process, but also during the storaging time. You have the degassing process, a lot of influences there. It depends on the coffee quality, the roasting degrees, the grinding degree, a lot of influences of the degassing process. So what we want is to save the aroma, and therefore we measure the oxygen level there. We measured the oxygen on the old way, like we have in gas extraction, to put this gas to the analyzer, or the probe is analyzed in the oxygen analyzer. And that is very, not difficult, but it's very not continuously. So when you have more silos, then you have a lot of time that you lost during the separate analyzing time. So therefore, we develop a new equipment, our oxygen transmitter, and also our oxygen transmitter box that we put on each silo, and therefore we can analyze the oxygen level inside the silo. So we save the aroma to put the oxygen level lower than 2% and to keep the coffee fresh. And this is in regulation, where we flush it with nitrogen through the coffee, and therefore we have the best aroma profile. What also possible is that we have a CO2 analyzer inside this transmitter box, because when you have degassing time, then you have a lot of money that you lost during this storaging time. So it's an experience value that your storaging time is an experience value, and therefore with this CO2 measurement we can see if the coffee has finished his degassing time. So I think now we can grind a little bit, and we start with the grinding process, and to take some probe, one without and one with densification. So now we start.
Now the grinding and densifying process is over, and we have two results here. On the one hand, there is the undensified coffee, and on the other hand, there is the densified coffee. I think that are two very good results. What do you think, Thomas?
Yeah, Carsten, so we see it on the undensified coffee, the chaff is there, is not destroyed, and the densified coffee is compact, and there's no chaff anymore in the coffee. So this was a small part from our R&D center here in Emmerich. So we hope that you like our part here, and thanks for your attention, and see you next time. Bye-bye from my side.
Yeah, also from my side. Thank you for watching, and goodbye. Hello again. I hope you enjoyed our little tour through our R&D center. Of course, this were a lot of information, but we want to add some more information.
Correct. So we don't forget something, but we can add a little bit. So when we look after the roasted coffee transport, like the pneumatic transport system, we have a lot of solutions there, from lower capacity up to a very high capacity. And also the dense phase system is also a gentle pneumatic transport. It's very good for the roasted coffee. And when we look to the energy cost, also the mechanical transport for shorter ways have also advantages there. And a small point is that the silo capacity from the ground coffee is up to 5.4 tons. So this was only some small additional points. I think we have also some advantages from the grinder.
Yes, of course. I want to add them too. When you think about maintenance aspects at the grinder, then we should say that it's very easy to remove all of the rollers in the different stages, and all rollers are cooled with water inside. Yeah, what is also important is that we have special knockers on the sheet metal that remove all the time the ground coffee, so that you can be sure that with every batch you have sorted coffee. And yes, that was it from the grinder. But we talk a lot about the grinding process and how to control the fine particles. Now the question comes up, how can we check the fine particles?
Correct. So each customer has his own quality check there. Here at our PROBAT laboratory we have we have our own checking there. So we can go to the small room and look after our standard analyst there.
Yeah.
Come with us.
I just follow you, Thomas, and grab the camera. Okay, wait for me.
Carsten has just arrived.
Yeah.
So here in our is our standard analyst. We have on one side our moisture analyzer. So it's also a drying cabinet. And we can measure the green coffee, the roasted coffee, and all other products like sunflowers, cocoa. Everything is possible. Here on the one side is our laser analyzer, that we can check the ground coffee distribution or the particle distribution. On the back side we have our bulk and temp density measurement, and also for sure our color measurement. The Colorative 4 is our own brand, and our small grinders, our lab grinders, because we grind it before we measure it, also grinding for the green coffee. So especially for the laser analyzer we get the result there, and there we have some a small picture or laser analyst, and you can see here's especially espresso grinding, and we have 3 values that we look as important values. The customer has his own values maybe, but we have our D63 value, that is after the D measurement, but also the X50 value and the particle size lower than 100 microns. So that are the important particles or the values that we look after, and we can change it with our settings from the grinder. So like Carsten said in the video, not only the particle size, the degassing also starting during the grinding process.
Yes, and for that degassing process we can say that we have less degassing with fine ground coffee, and we have even more degassing with coarser ground coffee.
Correct, and there are much more influences from the gathering, like the roasted color. When you roast very dark, then we have much more degassing there, and also the coffee variety has an influence, like the Arabica has more rest gas than the Robusta coffee, because the cells are bigger and more gases are in the cells. And when we look after the fast degassing, that's also a very big topic for some customers, then you have an influence with temperature, the storage temperature, and also the under pressure during the storage in your silo. And with our degassing unit, we can measure this degassing by time. So we have 6 gas-tight glass bulbs. Inside the glass bulb we measured the pressure and also the temperature, and we calculated to a value that we call milliliter gas per 500 gram coffee, and we can evaluate it in an extra software, and you can transform it to Excel. So with this unit you can measure your degassing and see what really happened after the grinding process. So the most gas coming out during the first 2 hours, but the degassing process not finished then. So it's very long period. So it depends on the grinding degree, roasting color, and so on. A lot of influence, and we can measure it here with it. So this lab unit, you can rent it here from PROBAT, but also can buy it, for sure.
Yes. And yeah, when we're talking about degassing and the end of degassing in the ground coffee silo, sometimes this process doesn't end in the ground coffee silo. So we have an ongoing process, maybe in packages. We saw this on our last, or on one of our pop-up stories. So yeah, you can see that when you have a package with a valve or without a valve, you have different degassing processes inside these packages. When we now think about the capsule, then yeah, the part or the degassing of storage is also very important.
Yeah, correct. So it depends really what the customer wants. So when we look after a capsule, then one thing is the material for sure, and we can see it here. Here we have a capsule with no degassing, with a flat surface and no overpressure there. That was what the customer really want. So you don't want this this overpressure inside the capsule because it's not going in the espresso machine, for example. And on the other side, we have a capsule here where we have an overpressure. So during the storaging inside the capsule, the degassing is ongoing. So it's not really finished like the other one during the storaging time. So it's also in the capsule ongoing. And some example from a business capsule. So this is what the customer wants, a very hard capsule, very strong. And on the other side, we have a soft capsule. Here we have the degassing is not finished during the storaging time. And so that is not what the customer really wants. So it's not only the degassing, also we want to have the same quality in each capsule. So depends on the amount of the coffee that inside the capsule. We want to have the same quality in every 7-gram capsule there.
Yeah, and for that we want to have all the time the same particle distribution, and we want to avoid demixing. And therefore, you saw it in the video before, we use special ZIF vacuum systems. That is a closed system and has also the best aroma protection. So would you say something about aroma protection, Thomas?
Yeah, that's an important point because we want to control, like in the video we said, to control the atmosphere in the silo, and therefore the aroma protection is very important. So the best way is to save the aroma from the grinder to the packaging machine. So all the time we want to have a really aroma protection there, and therefore we flush the silo with nitrogen and control it by an oxygen measurement system. So our intention was that we find a solution for another kind of oxygen measurement, because the old way is very high investment, and you have a very long probe analysis pipe before you have the result there, and therefore we look after other types of measurement system, and therefore we have some solutions. One solution is especially for a transport system like a ZIF, a vacuum conveyor. This is a really low investment or cheap investment oxygen transmitter. It can easy install or mount it in your pipe, and you have then very fast your oxygen value. And another one is when you have mobile containers, for example, and you want to measure the oxygen level inside the mobile container. So it's around your factory, the mobile container, because it's stored not at one place, so around complete factory. And so we have, this is only a prototype. We have a chemical oxygen measurement sensor, and we can send this signal from the sensor with a radio frequency module to your control. So it's very important that it's very low energy consumption from the sensor, so we can work with an accu or a battery, so for the energy there. And we talk about the oxygen transmitter box. So inside this box here we have a forced flow. So with the other one we have a diffusion. So the gas must go to the sensor. Here we have a small pump inside. So we have a pre-filter, then comes a small pump, and then the oxygen measurement system. So the gas coming in, and on the other side the gas goes out and maybe back to the silo or whatever. So this box we can add with, for example, the CO2 and also a CO sensor to measure inside the coffee the CO2 level, for example. And this is very important because what I said in the video, it's almost an experience value when the storaging time finish and ready for packaging. And with the CO2 value, we want to compare with our degassing unit to see when really the degassing time ends and when the CO2 is not rising anymore, and then we are ready for packaging there. So it depends on what really your requirements is for the measurement point, and therefore all this stuff here is has a lower investment like the older way, and very interesting for each customer there.
Yeah, of course. Thank you, Thomas. I think our session comes now to an end, and what we really want to point out is that we have all the opportunities to make your coffee the best you want to have with our equipment in the R&D center. So this is kind of invitation that you can come to Emmerich and bring your coffee, and we will create your best coffee with all our technique we have here on site, with the laboratory and all the knowledge we have. Yeah. What I also want to say is that we have another heat event next week. We were talking there about the advantages of the Proforte system. This is also very, very interesting, so feel free to join. And yeah, I want to say goodbye and thank you for watching the live stream.
Thank you and Merry Christmas.